Have you ever noticed how the tools we use to build things are fundamentally changing now that AI is just like constantly looking over our
Oh,
shoulders?
absolutely. Yeah, it's this profound shift.
Right. It's like we're suddenly designing our workspaces not just for human hands anymore, but for these invisible digital apprentices.
I mean, we've spent decades optimizing tools for human readability, human ergonomics and logic. But the moment you drop an autonomous agent into that workflow,
Everything changes.
exactly, the whole definition of what makes a tool good or efficient completely flips on its head.
And that is exactly our mission for this deep dive. Today, we're exploring a pretty fascinating 2026 presentation by the developer at LUK036. It's titled CMake versus XMake Build Systems in the AI Era.
It's a great piece, really insightful.
It is, but I want to be clear right out of the gate here. Our mission today isn't just to talk about, software engineering or getting in the weeds of code.
Right, because it's much bigger than that.
Exactly. We're using this specific rivalry to explore how the rise of AI agents is entirely rewriting the rulebook for how we evaluate the tools we use every single day.
Yeah, it serves as a perfect lens into the future of our workflows. When the entity doing the heavy lifting changes from a human to a machine, the infrastructure, it has to evolve accordingly.
Right. And I know what you might be thinking listening to this. C++ build systems sounds like the driest, most inside baseball tech jargon imaginable.
It really does.
But I promise, this isn't just dry code talk. The entire future of how AI writes software literally rests on this invisible infrastructure.
Yeah, to put it in perspective for you, a build system is essentially the general contractor of a software project.
Okay, I like that.
Like, imagine you're trying to build a massive skyscraper. Before you pour a single ounce of concrete, you need a highly organized manager, someone
Right.
who perfectly coordinates the plumbers, the steel deliveries, the safety
All the
inspection.
blueprints across different cities, right?
Hey, exactly, simultaneously. And that is what a build system does for code. It tells the compiler when to work, it manages dependencies, organizes testing. And honestly, it is surprisingly hard to get right.
And right now, there's this massive philosophical battle over how to do it in the age of AI.
Huge battle. Yeah.
So to really grasp the weight of this, we first have to understand the incumbent heavyweight champion. We're talking about a system that has ruled this industry for, well, over 2 decades.
You really can't understand the current revolution without understanding the king. And in this case, the king is CMake.
CMake, right?
Yeah, created way back in the year 2000. So that makes it over 25 years old.
Which in internet years is practically ancient history.
Oh, it's the Mesozoic era. But it is the undisputed industry standard. I mean, if you look at tech giants and massive open source projects, things like Qt, LLVM, OpenCV, TensorFlow,
But I'll use it.
they all rely on CMake as that general contractor holding their code bases together.
But heavy wears the crown, right?
Mm.
Looking at the presentation, CMake has some pretty serious historical baggage.
Oh, definitely.
Like it relies on this custom DSL, which is a domain-specific language. And it uses these things called generator expressions for setting up its flags.
Right, the flags.
And for those unfamiliar, flags are basically the command line switches that tell the compiler exactly how to behave. Like, optimize this for speed or use less memory, that kind of thing.
Yeah, and those generator expressions in CMake are notoriously cryptic, just incredibly hard to parse.
Right.
And on top of that, you have the dependency problem, because C++ didn't actually have a standard package manager until, what, 2023?
Yeah, 2023, which is wild to think about.
Right. So dependency management in CMake has always been sort of bolt-on. You have to use external tools with names like CPM, VCPKG, or Conan just to fetch the external libraries your project needs.
So super fragmented.
Very. If you look at the sample project the author provides in this presentation, just to get a basic CMake setup running, it requires 4 different files and about 320 lines of code.
Okay, let's unpack this using our skyscraper analogy.
Yeah.
Because it's like hiring the most capable general contractor in the world, right?
Sure.
They can build a house, they can build a rocket ship, they can do anything. But their contract and their daily instructions are written in ancient hieroglyphics.
Yes, that's highly accurate.
And just to get the plumbing installed, you have to hire 3 separate third-party translators
Yeah.
just to explain what a pipe is. That's what the CMake setup looks like to me.
It really is. I mean, the syntax is very much a love it or leave it situation for developers. You have like strings nested inside strings that look like complex mathematical equations just to tell the compiler where a file lives.
So why is it so dominant then?
Well, the reason CMake achieved absolute dominance is because it solved an even bigger nightmare at the time, which was cross-platform compiling.
Oh, right, making it work on Mac and Windows and Linux.
Exactly. Before CMake, trying to get C++ code to run on a Windows machine, a Mac, and a Linux server meant writing completely different build scripts from scratch for every single platform.
Which is just a massive headache.
Total nightmare. CMake swooped in and basically offered a deal. It said, write this ugly hieroglyphic code once, and I will automatically translate it for every operating system.
Ah, so it was a lifesaver, even if it wasn't pretty.
Exactly, a total lifesaver.
But the industry is shifting now.
Yeah.
Developers are getting tired of translating those hieroglyphics, and that is where the modern challenger enters the ring.
Yes, XMake.
But as we're going to see, simplicity alone isn't enough to dethrone a king.
No, it never is in enterprise tech. But yeah, the challenger is XMake, created around 2019, so it's about 6 years old.
Pretty new.
Relatively, yeah. And the biggest fundamental shift is that XMake doesn't use a custom cryptic domain-specific language. It uses Lua.
Oh, yeah.
And Lua is a real, highly readable, widely understood programming language. It's been used in everything from, video game development to embedded systems.
And the contrast in the presentation is staggering.
Mhm.
The author takes the exact same sample project that took 4 files and 320 lines in CMake and writes it in XMake.
And what's the result?
Just one file, 144 lines of code.
Wow.
Right. That's 2.2 times fewer lines and 4 times fewer files. Plus, XMake has built-in package management, so it doesn't need all those bolt-on translators for the plumbing.
Right, it's all native.
Yeah, and it only takes one single step to actually build the project, compared to CMake's 2 steps. The author literally calls it the cargo of C++, would just run one command and you're done.
Which, on the surface, sounds like a total knockout.
It really does.
But the presentation takes this brilliant turn here by looking at the broader context. The author creates a traditional scorecard evaluating both systems on the metrics human engineers usually care about.
Right, looking at the big picture.
And when you tally it up, it's actually a dead heat, a 5-5 tie.
Okay, let's break down that scorecard. XMake clearly wins the categories we just mentioned, right? The learning curve, the overall lines of code, and the built-in package management.
Yep, it sweeps those.
But CMake punches right back in categories that are just as crucial for large companies.
It does. CMake wins heavily on CI/CD integration, which is continuous integration and continuous deployment.
So the automated servers that build and test your code every time you save it.
Exactly. Because it's a 25-year-old standard, CMake is universally pre-installed on every automated server runner on the planet, like GitHub Actions.
That's a huge advantage.
Massive. It also wins on ecosystem maturity, and it wins on what's called first-class install and packaging.
Which means what exactly?
It means downstream consumers, like other companies that want to use your code, they actually expect a specific handshake. They expect to see CMake's specific find package commands.
Ah, so if you don't have them, they can't easily use your work.
Right. And finally, CMake wins on built-in integrations for sanitizers, which are vital tools that catch memory bugs before they crash a program.
So if I'm an engineering director looking at this scorecard, I'm thinking, if it's a 5-5 tie on paper, why would any enterprise take a risk on a 6-year-old newcomer? Like, why fix what fundamentally isn't broken?
That is the eternal corporate question.
Right. If CMake works on every server in the world, the pain of the hieroglyphics seems like a fair trade-off for absolute stability. You don't rip out the foundation of your skyscraper just because the new contractor has better handwriting.
Well, this raises an important question. For human developers in a corporate environment, a tie always goes to the incumbent.
Naturally.
The transition costs of rewriting your entire infrastructure are just way too high. But a new developer has entered the chat, and this new developer completely changes the mathematical reality of that scorecard.
We are, of course, talking about AI.
We are. The moment we introduce AI agents into the coding process, the traditional metrics we just discussed, they become completely obsolete.
Because the AI doesn't care about ecosystem maturity.
Exactly. The AI doesn't care if a tool has a massive 25-year ecosystem or if it's pre-installed on an enterprise server. The new question is entirely different. Which build system is better for an autonomous AI agent that has to read, understand, modify, and verify code all on its own?
Here's where it gets really interesting. Because when we talk about AI, we have to talk about token economics.
Yes, tokens are everything.
Every single piece of text, every word, every space, every line of code is broken down into tokens that the large language model have to process. And every token costs 2 things. hard computational money, and context space in the AI's limited short-term memory.
And the math from the presentation paints a very vivid picture of this.
Walk us through it.
So, when an AI agent needs to read and understand the CMake project, it has to jump around and ingest 4 separate files. It has to read those 320 lines, and it has to make 4 distinct API calls just to fetch all that context.
Okay, so it's doing a lot of jumping around.
A ton. In total, the agent consumes about 4,500 tokens just to figure out what is going on.
But when that same AI reads the XMake project, it's just one file, 144 lines. A single API call. That is roughly 2,000 tokens consumed.
It's less than half.
Right. Mathematically, XMake is 2.3 times cheaper for the AI to process and far more linear. Think about it like this. Having an AI read CMake is like getting into a taxi, and the driver runs up the meter by taking the scenic route, hitting every detour, and making 4 different stops before getting to your destination.
And XMake is a straight shot down the highway. The meter barely runs.
Exactly.
But, it goes even deeper than just reading the code. We have to consider how an agentic workflow actually operates.
Right, because agents don't just read.
Exactly. When an AI writes code, it doesn't just type it out and walk away. It actively tries to compile the code. And if that build fails, the AI has to read the resulting error log, figure out what went wrong, modify its own code, and try again.
Like a loop.
Yes. And if a build fails in CMake, debugging that error log is essentially an archaeological dig for the AI.
Oh man, an archaeological dig.
It has to trace failures across this complex chain of modules and included files, trying to find exactly where the error originated. But with XMake, debugging is simply reading the single file top to bottom. It is infinitely easier for the agent's limited attention span to manage.
So XMake is cheaper and easier for the AI to read. But reading code isn't what breaks projects, right? Writing it is. How does XMake perform when the AI actually has to generate the code itself?
Well, the presentation uncovers a phenomenon here that I find incredibly insightful. It's called the hallucination paradox.
Okay, let's lay out the facts first before we get into the paradox. CMake has a massive amount of training data available on the internet. We are talking about millions upon millions of repositories hosted on GitHub over the last 25 years.
It's a mountain of data.
While XMake, being newer and smaller, has about 100 times less training data available for an AI to learn from.
Right. And yet, despite that massive advantage in raw data volume, CMake's AI generation accuracy is significantly lower than XMake's.
I have to admit, I'm struggling to square that with how large language models usually work. We are always told that more data equals a smarter AI.
Right, that's the conventional wisdom.
The more you feed the model, the better its outputs. So if CMake has 25 years of training data and XMake only has 6, shouldn't CMake's AI agents just run circles around XMake?
See, what's fascinating here is that assumption makes sense on the surface, but we are hitting the limits of the data volume argument. This is the quality versus volume paradox.
Quality versus volume. Okay.
Because CMake has existed for a quarter of a century, its training data isn't just massive, it is incredibly noisy.
Noisy.
Yeah, it's full of different dialects of CMake. It is packed with deprecated patterns from 2008 that nobody should use anymore, but they're still sitting there publicly on GitHub being absorbed by the AI.
So it's learning from bad examples.
Exactly. There's very low syntactic consistency. So when an AI tries to generate a CMake script, it has this massive chaotic menu of historical options to pull from. That creates a gigantic surface area for AI hallucinations.
Oh, I see. It's like a smart text autocomplete on your phone. If it reads too many internet forums from the 1990s, it might aggressively start suggesting outdated chat room slang in the middle of a professional email just because it saw the pattern a million times.
That is a perfect parallel, yes.
The AI is learning bad habits because CMake's history is full of them.
Exactly. Whereas XMake's training data, while 100 times smaller, is highly consistent. It uses that clear, readable Lua syntax.
And it has a constrained API, right?
Yes, meaning it limits the options of what can be typed. There are simply fewer ways to be wrong in XMake. The guardrails are much tighter.
And the numbers back this up beautifully in the presentation. It tracks what it calls the agentic coding success rate. So when an AI agent attempts a task in CMake, it succeeds about 75% of the time.
Okay.
But when it attempts a task in XMake, it succeeds around 90% of the time.
That is a huge lead. I mean, that 15% delta represents the difference between a tool that acts as a helpful assistant and a tool that becomes a frustrating liability.
Right, because if it fails all the time,
Exactly. An AI that hallucinates or fails 25% of the time requires constant human supervision. You're always double checking its work, which completely defeats the purpose of having an autonomous agent in the first place.
You're just babysitting at that point.
Babysitting a machine. But an AI that succeeds 90% of the time, that is actually accelerating your workflow. So when the author scores these two systems specifically for the AI era, XMake wins 4-3.
Wow.
Yeah, it completely dominates in token efficiency, generation accuracy, error diagnosis, and agentic success rate.
So what does this all mean? If XMake clearly wins the AI era, does that mean we just throw CMake in the trash? Like, do we go back to those enterprise directors we mentioned earlier and say, burn down your 25-year-old CI/CD infrastructure? The AI likes this Lua thing better.
I don't think that would go over very well. And thankfully, the author provides a brilliantly pragmatic solution to avoid exactly that kind of corporate civil war. The verdict isn't to pick a winner and discard the loser. The verdict is a dual build approach. In fact, the very project used as an example in this presentation literally uses both systems simultaneously to get the job done.
That's fascinating. The strategy is perfectly split based on who is doing the work. You use XMake for the local development loop and your solo AI iteration.
Right, on your own machine.
Yeah, when you're sitting at your desk, writing code, testing locally, and having your AI agent refactor things, you use XMake. You do this because it's faster, it takes one command, and most importantly, it constrains the AI from making those costly hallucinations.
And this is the crucial part. When it is time to actually ship the product to the rest of the world, you rely on CMake.
For the heavy lifting.
Exactly. CMake handles the automated CI/CD pipelines on those GitHub runners. It checks the boxes for enterprise compliance. It handles the open source packaging, like generating the version headers and exporting those specific find package handshakes that the broader ecosystem absolutely depends on.
It really is the ultimate best of both worlds. And the presentation actually breaks down the math to prove the return on investment for maintaining two separate build systems, which I found so interesting.
Math is great here.
Right, because if using XMake saves an AI interaction just 2.5 seconds, and you do that 10 times a day, that adds up to, well, only about 1.7 hours saved a year.
Which sounds terrible. It doesn't sound worth the effort to maintain two systems at all.
Right. If you are just measuring raw time, it barely registers. But the author points out that the real return on investment is an error reduction, not just raw compilation speed.
Oh, error reduction.
Yeah. By moving from a 25% AI failure rate in CMake down to a 10% failure rate in XMake, developers experience 60% fewer AI failures overall.
60% fewer failures. If you're listening to this, think about the mental toll of fixing an AI hallucination in your own work.
It's exhausting. It totally derails your focus. It forces you to context switch out of whatever problem you were trying to solve just to babysit the machine. Eliminating 60% of those interruptions is a massive boost to productivity and, frankly, your own human sanity.
It proves a much larger point about the future of engineering. Managing the AI's cognitive load is becoming just as important as managing your own cognitive load.
Absolutely. And if you are sitting there wondering how to apply this mental model to your own life, even if you've never written a line of C++ code in your life, the takeaway is profound. We are rapidly moving away from a pick one universal standard mindset.
Historically, we forced one tool to do everything for everyone, everywhere. But now you have to ask yourself, who or what is actually doing the work at this specific stage of the process?
You use the tool that speaks best to the entity performing the task.
Exactly. You use XMake locally because it speaks clearly to your AI agent with tight guardrails and low token costs. You use CMake for deployment because it speaks clearly to your legacy enterprise servers.
Right. You don't force the AI to read ancient hieroglyphics,
Yeah.
and you don't force the enterprise server to accept a modern format. It just doesn't recognize.
It's all about translating the friction out of the process by meeting the worker, human or digital, exactly where they are.
We are essentially learning to be bilingual in our workflows, speaking human in one context and speaking AI in another.
That's a great way to frame it.
So, to quickly recap where we've been today, the dawn of AI coding agents is forcing us to fundamentally reevaluate the very tools we rely on. What we used to call the gold standard for humans might actually translate to highly expensive and error-prone for an AI.
Right.
And what we used to dismiss as a niche alternative is proving to be the highly optimized track for autonomous agents. So adopting a pragmatic dual-tool approach allows us to harness the speed and accuracy of AI without sacrificing the stability of massive enterprise standards.
It is basically a blueprint for surviving the transition period we are currently living through.
Which leaves us with a pretty wild thought to end on. If we follow this logic to its absolute extreme, if AI agents are already proving to be far more efficient and accurate when using tools designed with strict, constrained APIs rather than human-readable flexibility,
Oh, I see where you're going with this.
could we soon see a future where AI invents its own hyper-efficient build systems?
Mm.
Systems that are so mathematically dense and token optimized that human beings literally cannot read them anymore.
Wow.
We started this deep dive talking about AI looking over our shoulders to help us build. But we might be racing toward a future where the AI effectively locks us out of the very blueprints of our own software, operating in the language only it understands.
A system built entirely by AI solely for the benefit of AI. I mean, it's a daunting prospect that challenges our fundamental role in the creation process.
It definitely is. Something to chew on the next time you're setting up a new project or asking an AI to do some heavy lifting for you. Thank you so much for joining us on this deep dive. Keep questioning the tools you use every day, and we will catch you next time.